Who might have imagined that only 120 light years from us, there would be a planet on which the principal indications of life have now been found? Indeed, we are managing an outright magnum opus of the James Webb Space Telescope. This wonder of innovation looked with its sharp eyes at a far-off world and found the primary indications of extraterrestrial life there. The exoplanet K2-18B has been stunning science since the first investigations. This planet is clearly a rich water world and could harbor more life than our Earth. K2-18B is an exoplanet that has already earned its place in the history books of astronomy. A little more than 120 light years from us, the planet orbits a red dwarf star, and K2-18b gives a few significant indications of organic cycles, making it one of the most pursued objects of study today. James Webb was able to find 4 biomarkers of life structures in the planet's climate. Thus far, this is considered an outright exception. The exciting report now fills many hopes of finally tracking down real life in the universe. Thanks to the ideal spectrometer examinations by James Webb, researchers were quickly able to see that this world assumes an exceptional role among exoplanets. When the examinations showed proof of a lot of water at the start of the study, the analysts were already excited, and what followed could change our science forever. For the first time, we are looking at a planet that can answer the questions of what life really is and how it emerges. Moreover, this world could demonstrate to us that the variety of life in the universe is greater than we could have previously imagined. The questions of how many life structures there are in the universe and what they look like are not just important to researchers, but also to many regular individuals. With the investigation of K2-18b, we might be very close to answering these questions for the first time. For biomarkers not only provide proof of a world wealthy in water, but also, for the first time, serious proof of the presence of extraterrestrial life in the climate of K2-18b. Proof of methane and carbon dioxide was found, along with other things. The two gases, particularly when they occur together, are obvious signs of biological cycles and life. Dimethyl sulfide DMS was also found on K2-18b. DMS is a gas that is probably unfamiliar to many, and on Earth, it's not that remarkable. However, in the universe, it is. Dimethyl sulfide, or DMS for short, is produced during the digestion of green algae and occurs in large amounts near oceans, seas, and large wetlands. You can already imagine that the discovery of DMS on a planet means nothing less than that there must be life in the expanses of this exoplanet. Green algae are the simplest life forms on our planet, and they likely populated the ancient Earth seas well before the first simple fish, snails, and mollusks showed up. Anyway, algae were probably the precursor to this life, and these plants might be one of the keys we need to understand the evolution of life. DMS on K2-18b should be seen as confirmation that there is, at the very least, green algae in the planet's seas. Where there is algae, there can be further life. Despite its shocking nature, the find is still being treated with caution. Trustworthy researchers do not want to discuss finding the first aliens just yet, but despite everything pointing to it, DMS, together with methane, carbon dioxide, and large amounts of water, are serious signs of the first livable planet we have found in the universe. Let's investigate the gas methane. If we consider how closely methane is related to life, the possibilities for life on K2-18b increase significantly. James Webb's exact spectrometer investigations showed a combination of methane and carbon dioxide, indicating a biologically dynamic world. By comparison, Saturn's moon Titan, for instance, also has a lot of methane, but other biomarkers, such as water or oxygen, are absent. It is probably uninhabited, or perhaps only some very simple methane-based microbes exist. Whether seas with warm water and algae eventually produce higher life forms is one of the great secrets of the development of life, and that is exactly what we need to uncover. K2-18b and the intriguing discovery of biomarkers in the planet's atmosphere could be another significant step towards understanding how life emerges in the universe and how it spreads on Earth. Methane is primarily produced by microorganisms. Other significant sources include the gastrointestinal tracts of ruminants and large rice paddies. Methanogenic microorganisms don't live in methane, but produce it during their metabolic cycles. Along with DMS, the methane stores on K2-18B suggest, at the very least, abundant vegetation on Earth. Green algae and some phytoplankton species produce huge amounts of DMS, which can then be found in our planet's air. DMS is produced by decay processes in coastal environments, and from there it enters the air. What exactly does the surface of K2-18B look like? We can do a lot, but unfortunately, we are not yet able to look at the surface of exoplanets. The James Webb Telescope uses its spectrometers to examine light that distant planets absorb from their stars and then re-emit. The interactions create a unique pattern of light at different frequencies. Water and seas reflect light differently than forests, mountains, or deserts. The Webb telescope can look at the light in the planet's atmosphere for gases and thus find biomarkers such as methane and DMS. With K2-18B, our technology allows us to see a kind of light signature of the planet, but we cannot yet get a detailed picture of the surface. We see the vapors of the seas, metabolic byproducts of green algae or single-celled organisms, and we might be able to detect the carbon dioxide exhaled by life forms that inhabit such a world, but we cannot see these living things. So, unfortunately, we can't determine exactly what they look like. Data from the James Webb Space Telescope tells us that K2-18B is a huge water world, about 8.6 times the size of our Earth and covered in a thick hydrogen atmosphere. This planet is one of the so-called ocean worlds, a class of planets that researchers have recently discovered in the universe. The discovery of ocean worlds was quite a shock because scientists previously believed that water in the universe was relatively rare. When this new class of planets emerged, it was as though gigantic, infinite flying water droplets had suddenly appeared before the eyes of analysts. Ocean worlds are significantly more covered by water than our Earth and are altogether larger than normal rocky planets. This makes this type of planet especially exciting because, where there is so much water, the likelihood of life is extremely high. These planets are also often much hotter than our Earth and could be something like enormous, warm greenhouses. If the planets are not too hot, they would provide ideal conditions for the rise of rich life. Imagine a sea-covered superworld with an abundance of life in its waters, like the most beautiful reefs in our oceans. We also can't rule out the possibility that such a world could produce higher living things bound to the water. Civilizations that inhabit water worlds could be unusual hybrid creatures made of fish and intelligent beings. K2-18b might be the first indication of abundant life in the universe, and we can hope that our sci-fi ideas of crazy aliens and beautiful living things will soon materialize. We'll have to wait and see. Right now, researchers are working on new technology that will allow us to examine biomarkers and metabolic products on distant planets even better, and thus determine whether there are further similarities to life forms on our planet. A mysterious, strange glow around JWST-76b. JWST-76b may not be one of the hot candidates for finding life in space, but this planet is continually presenting astronomers with new secrets. It shines so oddly. The Exoplanet is a hot Jupiter in the Pisces constellation and orbits so close to its star that its day side is heated to an incredible 2,400 degrees Celsius. That's hot enough to vaporize iron. But it's not just these extreme temperatures that intrigue researchers. In recent years, scientists have noticed a peculiar phenomenon across the planet's surface, and this glow could also solve one of the greatest mysteries of the universe. The greatness impact is caused by an unusual environmental light scattering on the planet. It is produced by dim mountains or thick cloud layers. When sunbeams hit water droplets or small aerosols, they create a ring-shaped glow, a brilliant radiance around the shadow cast on the mist. Why does this impact happen in the climate of an exoplanet like JWST-76b? The answer, in all likelihood, lies in the surprising climate of this exoplanet. It is tidally locked to its star, continuously pointing its day side towards the sun, while the night side is forever in darkness. This results in a very hot day side and a cold night side. On the hot day side of JWST-76b, metals such as iron evaporate and spread throughout the atmosphere. Solid winds carry the iron fog to the cooler night side of the planet, where it cools and condenses again. Then, iron literally rains on this planet, and these vanishing and gathering metal mists create the perfect conditions for a brilliance impact. Researchers suspect that when the light from the nearby star hits these iron mists, it is reflected and dissipated, creating the ring-shaped glow around the planet. But now we need to take a closer look at the true nature of the flicker effect on this world, because the shine around JWST-76b is not only an intriguing sight, but also a signal of fascinating physical processes at play. Such abnormal cycles are occurring that they should make us question the reality of absolute physical laws. We have been able to identify increasingly bizarre phenomena in exoplanets with the James Webb Space Telescope, and some scientists have begun to question whether we might need to revise our understanding of the universe through the lens of our old physics. We find exceptions to the rules by the dozen, and the universe is increasingly looking like a bizarre wilderness of peculiarities, impossibilities, and scientific paradoxes. Subscribe to the channel now, and stay tuned for each new video.